Alright you guys, so in this video I am going to show you how to work through an R Markdown file. I realized when I was putting all the different parts of Lab 1 together that many of you may not have worked through these kinds of R scripts, and in order to help you get through those, I'm going to walk through the first one with you in this little tutorial video. So the first thing you're going to do is you're going to download the Markdown file. It's the name of the file and then .rmd. It's going to be available on Moodle. I'll place it on the Lab 1, Prelab 1 link so that you see it right there. And it's going to look something like this that you see. It's going to have a big red circle and an RMD there. So what you'll do is you'll right click on that and you're going to open it with RStudio, which is the default application. And I'm going to maximize this so you can see it a little bit better. It's going to take a minute to load up here. So what you'll see is all the Markdown files that you'll work with will look something like what you see here. And the first thing that we're going to focus on is all the metadata up in the upper left-hand corner of this main console window, or the main Markdown window rather. You see the title, which is the title of the file, and that's the title that I've given it. You see my name. You see the date that I put in there when I first created the file, and then a couple of other relevant bits of information. For example, what kind of output do we want? Sometimes that you may see that as being PDF document or Word document. For the purposes of this class, we're only going to have our Markdown files output HTML files, so that won't change. And then output to console means that when we run code up here, it'll output the results down here in the bottom right below the script file. And you'll see that here in a little bit. So what you'll need to do as a first step is to change the name, everything inside the quotes, and the date using the same exact format. And again, everything inside the quotes, because if you remove the quotes, you'll run into errors, and if the date format is a little bit off or is not exact, you may run into errors there as well. So remember to change the name and the date. You're welcome to change the title as well, but I'm not requiring that. So, and I put a little reminder here in the first couple lines of text. So there are lots of little bits of code and Markdown that make things cleaner for me as the instructor and for Nina as the TA to help identify certain chunks of code that we want you to focus on, or when you actually knit this entire script, and a script is just a whole bunch of code stacked together to create one document, essentially. When we knit this script, when we run it all together, these little bits of code will come out differently than what you see here. For example, this on line 11 you see like 5 different asterisks or asterisks. And what that shows up when you run the script is it will just show up as just a solid line that goes across the document. So for the first task that I want you guys to accomplish in this particular script file is you need to load the necessary libraries to accomplish all the different tasks I have you running in this script, and you have to install those packages but then load them as libraries as well. And this two-step process is required if you haven't done this before for these particular packages. I have already installed these packages on my computer, so I have pound signs in front of them. And when you want to include code that you don't actually want to run, you can write the code out, but then you comment it out. And we call it commenting it out in R by putting a pound sign in front of it. So you can see here, I have the install packages rgdoll there. If I want to run that, I run Mac, so I'm going to hit Command and Enter. But if you run Windows, you'll use, I think it's Control and Enter, I believe. But you can also just highlight a line here and then go up here and hit the play button. And that will play that particular line of code. And you can see down here in the console where it says Install Packages rgdoll, and it's going through and installing that particular package. And sometimes it takes a minute. That's why I've commented these out, because I already have all of these installed. So installing them again really does nothing for me but takes up time. All right, now what it's doing, so now that I've installed these packages, you have to do what's called you have to use the library command, and the library command actually takes that package that you've installed into R and makes it usable in this particular session. So that's why we have all these library plot.kml, rgdol, and all those other packages that we've installed up here. That's why we have the library command there. All right, now that you've done that, if you've already installed all of these, it's good to comment them out like I have here, because when you go to knit the script at the end, and I'll show you this at the end, when you go to knit the script, if you still have these as runnable code without the pound sign, you'll run into an error. So that's why once you've run these, it's good to comment them out using the pound sign. So now that we've done that, the next thing you need to do is set your working directory. And you can do this a couple of different ways in RStudio, which is what I want you guys to use. So you can do it either by writing out the code, as I've done here, set WD, and then you set your location in quotations, or you can go over here to Files, and you can actually manually search for a particular folder. You hit these three dots, and you navigate to the folder that you want to set as your working directory. Mine is on Dropbox. So you'll see here, and I'll set it as that, and I say open, and then you go to the More button there, and then you click Set as Working Directory, and you'll see here down the console, it basically writes out that line of code for you. So it's a little bit more automated. It might be a little bit more user-friendly for some of you guys, so feel free to use that way as well. But really the important part here is to make sure that you set this particular path to the folder that you're going to keep all these files in. Okay? Now that you've set your working directory, you can read in your GPX file. So that's going to be the file that has all your tracks information in it, and the format of the name will be something like this. I organize all my data in a data folder within whatever working directory I'm working in, so that's why it says data / and then the file name .gpx. So we'll run that, and you can see here if we just type head dat down in the console, it'll bring up the first 5 or 6 lines of that data file. But this data file is a little funky, so we have to reformat it. You see, this is a lot more than 5 to 6 lines. So this next line of code actually does that, sets it as a data frame. So we say tracks as data frame. Oops. Accidentally put a little F in there. So we say tracks, and then if we say head tracks, you can see there it actually looks like a standard, almost like an Excel file, and that's really what a data frame is. It's a file that you could think about transferring into a single spreadsheet file, and we will end up doing that at the end of this particular, at the end of this Markdown script. All right, now that we've done that, you can see that the third thing I want you guys to do is save the data frame of tracks as a CSV. That's a comma delimited file. Many of you have probably worked with CSV files. And CSV files are really useful because you can open them and work with them in Excel, but they're also files that R can use and work with. R cannot work with Excel files, but this is kind of the next best thing, actually. So what we do here is we're writing this tracks file as a CSV, and we're saving it in our working directory. So you can see here tracks. Tracks.ll, I'm just basically reading this file back in. And then class tracks.ll tells me what kind of file it is, just to make sure that the code that we ran actually worked and converted it to a data frame. You say, okay, you use the class command to see what kind of data file it is, and our code worked. It's showing up as a data frame. So now what we do is we say, okay, now that we have a data frame, we want to make sure this is what's called a spatially referenced data frame. And that's why we use this coordinates command here. We say coordinates for the tracks LL file. We're going to set those as the long and lat columns in our data file. So if you go back up here, you see we have, hopefully you guys can see my cursor down here. I'll try to highlight it here so you can see this. So you see this long column and lat column. Those are our longitude and latitude for our tracks. And we're telling R that we want this to be a spatially referenced data frame and that we want the longitude and latitude columns to be the spatially referenced data for this particular data frame. So we run this, and then if we run head again to show us the first few lines of this particular data frame, oops, it's tracks. You can see it looks a little bit different. Coordinate reference system arguments. So now that we've made it a spatially referenced data frame, but we haven't set what kind of coordinate system we want to use. And any of you who have worked with geographic information systems knows that this is kind of a critical component to making sure that all our data is in the proper format. So that is what we're going to do here in a couple of steps. But then we're going to write this out. Right now, we're going to write this out as an ESRI shapefile. So this is the kind of file that we can bring into ArcGIS and work with relatively easily. There you go. You see we converted it to a shapefile. We checked to make sure that our command worked by using the class command. And you can see that it is a spatial points data frame. That just means it's a spatially referenced data frame. And that's pretty much it. So now that we've created the shapefile, we're going to read it back in, and we're going to set the projection for this particular data frame. So when Maverick collects data on you, it collects data on latitude and longitude. We can set that to be a number of other things if we want, but we're just going to keep it as latitude and longitude because it gives me an opportunity to show you guys how to do data conversions and projection conversions in R, as we're doing here. So Maverick is going to collect data on you in latitude and longitude, and we're bringing that file. We've written it as a shape file, and we're going to bring that file back in and convert the projection. Here, this line of code, we're setting the projection as latitude and longitude with the datum of WGS84. And so let's plot that and see what it looks like. So these are what my home range data points look like. These are what my tracks look like essentially. I recorded my data earlier in August. I think it was the first week in August, and these are what my tracks look like. You can change all of these different settings. You can see I can change this to black. Changes it to black. I can change what my points, what shape I want my points to be. There are a lot of different things you can do to manipulate how this looks. And we'll get more into that later in the semester. Feel free to kind of mess around with it a little bit if that's interesting to you. So here we're just checking the first few lines of our data file again to make sure everything's lining up. You can see we have our latitude and longitude, and those are showing up as coordinates. But now we want to take the latitude and longitude coordinates and convert it to Universal Transverse Mercator Zone 15. UTM is really, I think it's the most commonly used geographic coordinate system or projection system, at least here in the U.S., definitely in fisheries and wildlife and conservation biology research. So we're going to take our latitude and longitude data and convert it to UTM Zone 15 datum NAD 83. And to do that, we just use this SP transform tool. Super easy, super simple. Then we'll plot it again just to make sure it didn't really convert our data in a way that was unexpected. And you can see you can use this if you highlight the plots tab. You can hit the back arrow and you can see that our blue, that's our latitude and longitude, and our red is our UTM file. So you can see that they look identical, and it didn't really do anything funky that was unexpected to our data points. So now we're going to write this file also out to a shape file. so that we can work with this particular file as a UTM Zone 15 NAD83 file in ArcGIS. So we've done that, and there are a few more steps that we need to go through to really complete this first part of Prelab1. So this particular line of code, we're just setting it up here. We have a spatial points data frame. Here we're just setting it as spatial points. So it's a little bit easier to work with. I'm not going to go into the details of why we're converting it this way, but it makes it a lot easier to work with points in ArcGIS as opposed to tracks. So here it will just show, this particular line of code will just help it show up as just data points that we can plot in ArcGIS. And again, we're setting our projection to UTM Zone 15, NAD83. Now what we're going to do is, at this point in the class, we've already talked about what an MCP is, a minimum convex polygon. But just as a refresher, basically a minimum convex polygon, a 100% MCP, is just a set of lines that essentially connect all your outermost points. And that is the simplest way to create a home range. So here we're creating three different MCPs, a 100% MCP, a 95% MCP, and a 90% MCP. And the 100%, like I said before, just takes 100% of your points and connects all the outermost lines. The MCP 95 will take the innermost 95% of the points and connect those lines, connect the outermost lines. And then a 90 does the same thing, but with the innermost 90% of your locations. So we're running all these. For the purposes of Prelab1 and for Lab1 in general, we are just going to create and use a 100% MCP. So you can see this is our MCP. So if we kind of pan back and forth, you can see that it connected all the outermost points of my relocation data and just created a minimum convex polygon. If we plot our 90th percentile, you can see that that red MCP there is a lot smaller. So I have a lot of points that you can see the outer edge of these points. There's only a few of those. Most of my points fall within this concentration. I live in Northfield, so the vast majority of the points that you see here fall in Northfield. And that shows up when you look at that 95 percentile or 95th percentile MCP. And then if we plot the 90th percentile MCP in blue, oh, here we go. So we have the 90th percentile, or 95th percentile in blue, and the 90th percentile in red. You can see as we decrease the percentile, of course our MCP will get smaller because we're including less data points. So now what we're going to do, since we're interested in using that 100% MCP to create the map for Prelab1, we're going to write that 100% MCP as a shapefile so that we can then bring it into ArcGIS. It comes up with all this other code that basically is showing you all the gruesome details of how it did it and the metadata associated with that particular file. Those really aren't interesting, or I shouldn't say interesting, but aren't important for the purposes of this lab. It's just kind of the default output that you get. All right, now that we've created our 100% MCP, we need to create a buffer that is 1,000 meters wide, so 1 kilometer wide. So to do that, we just use the gbuffer command, as you see here. And then we're going to take that buffer and plot it here. So you can see here that that actually creates a shape in and of itself. It doesn't actually drop a buffer on the outside of your MCP, but it creates a shape that includes your MCP, but then attaches a buffer on the outside of that. Oh, excuse me, let's do this real quick. So you can see now that we've added the buffer is in red, and then our actual MCP is in that blue color. So we are going to write this buffer as a shapefile as well. So that's really all you need to do with this particular Markdown script. Hopefully kind of walking through this has helped you guys become a little bit more familiar with our Markdown. Once you've run through each line of code and done the things that you need to do, as I said before, what you need to do is you need to go up and make sure you comment these out since you've already installed those packages. But I want to show you what happens when you don't comment those out. So if you encounter that error, you know what it looks like. So to comment out a large chunk of text, what you do is you highlight it, and in a Mac, you hit Command Shift and C, and you see it removes that pound sign. I think in Windows, it's probably Control Shift and C. But if we want to run this whole thing together, knit the script and create an HTML file, which you guys will be submitting, you hit the knit button. Oh, and you can see we ran into an error, and it tells you exactly where that error occurred. So it occurred on the first chunk, and this whole highlighted area here is what we refer to as a chunk. We ran into an error there. So if we comment this out and then we knit it, it should run fine. And sometimes it takes a couple minutes because it's installing libraries and performing some of the functions that I set up in this particular script. But you can see that it's at 100% now. It's going to pop up with an HTML file that has the answers and a lot of the extra code in here. And also the plots that I had you guys create. I am going to alter this code so that you don't have all this extraneous and superfluous stuff popping up that you really don't need to see, that is essentially useless for the purposes of this Prelab. But as I said before, I apologize for that. As I said before, this is really all you guys need to do with this first script. It should look something roughly like this. And now you have the home range file, your actual relocation points, and a buffer file that you can then bring into ArcGIS and create your map file. If you guys have any questions about this, feel free to ask me or come to office hours. We'll be working on this in class as well, so don't hesitate to ask. All right, thanks guys.